Okay, so we're going to talk about another theorem today, the conjugate pair theorem. It essentially says that if you're trying to solve a polynomial equation and all the um, coefficients in the polynomial are real, okay, you don't have any complex numbers for the coefficients of those terms of the power functions. So all of the coefficients of the polynomial are real. And then if you find a complex zero, a plus bi, where b is not zero, then a minus bi is also a complex zero of the polynomial. In other words, if you know one complex solution for the polynomial equation for real coefficients, then you automatically get another complex zero by changing the sign of the imaginary part. So if a plus b is a complex zero of a polynomial function with real coefficients, then the conjugate a minus bi is also a complex zero of the polynomial function. So that's called conjugate, by the way, if you change the sign for the imaginary part of the complex number. And remember, it has to be a polynomial with real coefficients. If there are some complex coefficients in the polynomial, then you cannot, the theorem is not true. Okay, so let's use this theorem to try to find the zeros of a polynomial p, which is x to the fourth minus 4x cubed plus 14x squared minus 36x plus 45. And if you are given that 2 plus I is a zero of p of x, okay. So obviously this polynomial p is a polynomial with the real coefficients. All the numbers, all the coefficients in this polynomial are real numbers, including the constants, including the constant 45. Okay, everything has to be real. And you know 2 plus I is a zero of the polynomial. Then you automatically get another zero, which is 2 minus I. Okay, that's called the complex conjugate of 2 plus I. And then what you can do is you can also use syntactic division for these two complex numbers to get reduce the polynomials. Okay. So let's just do this problem, by using the syntactic division. So as I said before, you can use syntactic division not only for real numbers but also for complex numbers. Okay, it just works the same way. So for the coefficients of the polynomial, 1, negative 4, 14, negative 36, 45, and 2 plus I, which is a 0 of the polynomial outside on the left, and do the syntactic division, and you do the same thing as you do with the real numbers. So you move down 1 first, and then you multiply 1 by 2 plus I, so you get a 2 plus I, right? Then you add the negative 4 with 2 plus I, so multiply up, add down. If you still remember how to add the complex numbers, you just do a real part and the complex part separately. So negative 4 plus 2 is negative 2, and you don't have anything to add or subtract with I, so you just have the I left. So you get negative 2 plus I. And then you need to multiply 2 plus I with negative 2 plus I. And that's easy. You can either follow it as I showed here, or you can use formulas. But either way, you're going to get the negative 5. So for example, if you follow it, you're going to get 2 times negative 4, 2, which is negative 4, 2 times I, which is 2I. And then I times negative 2, you get negative 2I, I times I, you get I squared. So 2I and negative 2I cancel. Now, negative I squared is negative 1, so I squared is negative 1. Negative 4 minus the 1, so you get negative 5, right? So you get the negative 5 by multiplying, put 2 plus I with negative 2 plus I. And then you add down, right? Multiply up, add down. 14 plus negative 9. And then you multiply 2 plus I with 9, and also show that that's pretty straight. You just distribute 9 on 2 and I, so you get 9 times 2, which is 18, and 9 times I, 9i. So you get 18 plus 9i below negative 36. Again, you just add real part by real part and the complex part. Imaginary part by imaginary part. Negative 36 plus 18, it will be negative 18, right? And you get plus and changed. And then you need to multiply 2 plus I with negative 18 plus 9i. Okay. And this can be easily done if you factor 9 from negative 18 plus 9i. You're going to get negative 2 plus I. Okay. Right? So that's just negative 2 plus I times 9. And then you multiply 2 plus I with that. So you get 2 plus I times negative 2 plus I times 9. And we already did the 2 plus I times negative 2 plus I, which is negative 5. And then you get negative 5 times 9, which is negative 45. So at the end, 45 plus negative 45, we get 0. All right? And that should be the case because, you know, it is a 0 of the polynomial, so you should get 0 in the remainder. So we have done, you know, one static division with the 2 plus I, but we also know 2 minus I is a complex 0 of P. So if you do the syntactic division with the reduced polynomial, which is, you know, what you get at the bottom line of the syntactic division for the coefficients, and then you should also get 0 in the remainder, right? Okay, so in other words, the 0 of 2 minus I should come from the reduced polynomial. Okay, right? So if you do the syntactic division of the reduced polynomial with 2 minus I, then you can reduce the the problem further. So what you do is just put the numbers at the bottom row of the syntactic division and do it with the 2 minus I. So you got 1, negative 2 plus I, 9, negative 18 plus 9i. So those are just copied from the bottom row of the first syntactic division. And then do syntactic division with 2 minus I. Okay. So again, move 1 down, you get 1, and 2 minus I times 1, you get 2 minus I. This time it's really straightforward. Negative 2 plus I plus 2 minus I. So negative 2 and 2 cancel, plus and the minus I cancel, so it gets 0. And then 2 minus I times 0 gets 0. And move, up. So put that 0 over 9, you get 9 plus 0, add down 9. And then you multiply 2 minus I with 9, you get the 2 times 9, 18, and negative I times 9 is negative 9i. And then just put that below the last thing, the last column, negative 18 plus 9i. Then you add negative 18 plus 9i with 18 minus 9i, you get 0. Negative 18 cancels with 18, and 9i cancels with negative 9i. So again, we'll get 0 in the remainder, which should be the case. Now, in addition to this, we also get the reduced polynomial of, from the second syntactic division, which has coefficient 1, 0, and 9. Okay, so we divide the original polynomial degree 4. Okay, if you divide once by syntactic division, you reduce the power once, and then you do another syntactic division, you reduce it further one time. So in total, you reduce the power of the polynomial by 2. So what you should get, it should be you should get this reduced polynomial starting with power x squared. So 1 will be the power of x squared, 0 will be the power of x, and 9 will be the constant. If you look at the second syntactic division. So you're gonna get you know x minus 2 plus I times x minus 2 minus I times x squared plus 9. Okay. If you still remember, x 2 plus I is 0 of the polynomial, so you get a factor with x minus 2 plus I, and also 2 minus I is a 0 of the polynomial, so you should get a factor with minus 2 minus I, and then the reduced polynomial you obtain eventually finally is x squared plus 9, as I already said. And then you set each factor equal to 0 to solve the equation. Then obviously you're going to get x equal to 2 plus or minus I. We already know that, but then you also have x squared plus 9 equal to 0. If we put that each factor to 0, you will solve x squared plus 9 equal to 0, and that's easy to solve because you just put 9 to the right to get negative 9, and take the root, you're going to get x equal to plus or minus 3i. Okay, you always get plus or minus, and when you take the square root of negative 9, you get a 3i, so it's positive or negative 3i. So we got 4 complex zeros: 2 plus I, 2 minus I, 3i, negative 3i, 3i, and negative 3i. So all of them are complex zeros. All right, and that's all the zeros for the polynomial because the degree of the polynomial is 4, the highest the power is 4, so it can only have 4 zeros, and those are all the zeros of the polynomial, right? Any questions? Okay, if no question, let's go to the next page. This time we're going to find the polynomial function with given zeros. So previously we just solved some polynomial equations. Given a polynomial, can you find the zeros? So that's solving a polynomial equation. And conversely, you can also find the polynomial itself given the zeros. So this is a problem in the reverse order. So for example, if you want to find a polynomial function of degree 3 that has 1, 2, negative 3 as zeros, so you are given the zeros of the polynomial. Can you find the polynomial? Yes, of course. You just multiply those factors. So 1 is 0, so you get x minus 1 as a factor of polynomial, right? 2 is a 0, so x minus 2 will be a factor of polynomial, and negative 3 is a 0 of the polynomial, so you get another factor from the polynomial, which is x minus negative 3. So you're going to get an x minus 1 times x minus 2 times x plus 3. Okay. Minus negative 3 is just a plus 3, right? So you just FOIL it one by one. So x minus 1 times x minus 2, if you FOIL it, you're going to get x squared minus 3x plus 2. And then just multiply that with x plus 3 and do it term by term. Okay. Just multiply each term in the first part with each term in the second part. So x squared times x, you get x cubed. X squared times 3, you get 3x squared. Negative x times x, you get negative 3x squared. Negative 3x times 9, you get negative 9x. 2 times x, you get 2x, and 2 times 3, you get 6, right? So combine like terms, 3x squared with negative x squared cancel. Negative 9x plus 2x, you get negative 7x. So at the end, it becomes x cubed minus 7x plus 6. Okay. It's saying find a polynomial. It's not the polynomial because you can still multiply the whole polynomial by constant, and it still has the zero, so 1, 2, and -3, right? If you multiply, for example, if you multiply 2 to the whole thing, that's 2 times x minus 1 times x minus 2 times x minus -3. That is still a polynomial of degree 3 with 1, 2, -3 as zeros. Okay, so just remind you that. Okay, one more example. Find the polynomial function of degree 4 that has real coefficients and 2i and 3 minus 7i as zeros. Okay, so this time you're only given two zeros, 2i and 3 minus 7i, and you want to find the polynomial of degree 4 with real coefficients. Okay, so how do you do that? First, we need to find the polynomial of real coefficients. All the coefficients are real, so that means the zeros of the polynomial we need to find will be complex impaired. So we know 2i is a 0 and -2i will be also a 0 because the complex conjugate of 2i is -2i. You change the sign of the imaginary part. So by theme we just discussed, because the polynomial has all real coefficients. So if it has a complex 0, then the conjugate also has to be a 0 with the polynomial, right? So 2i is polynomial, it is a 0 of the polynomial, then -2i has to be a 0 of the polynomial. Similarly, 3 minus 7i is 0 of the polynomial, and the complex 0, complex conjugate 3 plus 7i is also 0. So we actually know all of the zeros of the polynomial in this case, right? So 2i, -2i, 3 minus 7i, 3 plus 7i. Okay. So what you do is just do the modification of those factors. 2i is 0 of the polynomial, so then you get a factor of x minus 2i for the polynomial. -2i is a 0 of the polynomial, then x minus -2i is a factor of the polynomial. So 3 minus 7i is a 0 of the polynomial, so x minus 3 minus 3 minus 7i is a factor of the polynomial. And the lastly, 3 plus 7i is a 0 of the polynomial, so x minus 3 plus 7i is also a factor of the polynomial. Okay, if you remember the factor theorem. So you just need to multiply all of those 4 factors, and you can do it. It doesn't take too much time, but we can do it in an easy way instead of a hard way, because we got the complex numbers here, and you have 4 factors. So just make the simplified. So we got x minus 2i times x plus 2i minus -2i, so that's plus 2i. And then we got x minus 3, and then if you distribute the negative sign to -7i, it becomes positive 7i. And then we're going to group x minus 3, okay, and leave 7i by itself. And the last factor, again, you distribute negative sign to 3 plus 7i, so you get x minus 3 minus 7i. But again, group x minus 3 and leave -7i by itself. Okay, so what we can do is we can use the formula for what? A plus b times a minus b equal to a squared minus b squared. If you still remember that, that's called difference of square, right? The formula. So x minus 2i, x plus 2i, you can use a minus b times a plus b, where a is x in here and the b is 2i. So if you use that formula, you should get a squared minus b squared. So the first 2 factors will give you x squared minus 2i squared, okay? And also the third and fourth factors, you can also use the same formula, because you can treat x minus 3 as a and 7i minus b. So that's again a plus b times a minus b. So you should get a squared minus b squared. So it gives you x minus 3 squared minus 7 squared. Okay, so let's simplify it a little bit. All right, 2i squared. Okay, I squared is -1, 2 squared is 4, so you get -4. And there's a negative sign in the front, so it becomes x squared plus 4. Similarly, 7 squared and I squared is -1. 7 squared is 49, so you get -49. And you get the negative sign in the front, so it becomes plus 49. And then, you just for your x minus 3 squared in the second part. So you get x squared minus 6x plus 9. And then you combine 9 with the 49, you get the x squared minus 6x plus 58. And you still have x squared plus 4 in the front to multiply it. And, you just distribute, just the for it. Multiply each term, the first part with each term in the second part. So x squared times x squared equal to x to the fourth. X squared minus times negative x is negative 6x cubed. X squared times 58 is 58x squared. 4 times x squared is 4x squared. 4 times negative 6x is negative 4x. 4 times 58 is 232 if you do it. Okay, so then you just combine like terms. It looks like the only thing we can combine here is 58x squared and 4x squared. So that gives you 62x squared. So at the end, the answer will be x to the fourth minus 6x cubed plus 62x squared minus 24x plus 232. So that's the end of this section. Let's see, we still have 8 more minutes. Any questions? Let's see. Okay, we may do a little more in the next section if you don't have questions. So let me just upload 3.5.
Can you do like examples?
What example?
Like when you do a problem, maybe can you do an example on one of them to show us exactly how you do it?
Are you talking about the multiplication of the polynomials? The how to multiply those factors?
Yes, any kind of example.
Yeah. See, like if you try to multiply x squared plus 4 with x squared minus 6x plus 58. In the example, in the last example here, you just multiply each term of the first part with each term in the second part, right? So just distribute x squared into x squared minus 6x plus 58.
I think she mean like the example is hard to follow, like because it just I'm not speaking for her, but I just think this is what she means. That like it's kind of hard to follow because like at the top where you have like p of x equals x minus 2i, like it doesn't show which terms you multiplying, like, and when you be talking, like you kind of go a little too fast, so like my eyes just can't keep up with where you're talking about.
Oh, okay.
I feel like
This. Go ahead.
because it's already written.
Okay. Yeah. I think
Writing how to do it.
it's basically let me see. Okay. Let me see if I can do that now. I guess I'm going to. Okay. Let me get my pen. And, maybe just do one example, then you know how to do that. Okay. Where's my pen? Okay, let me get it. Oh. Okay. It's here. So I think okay, let me try to get the so share.
So, Mr. Liu, is the homework for this section gonna be uploaded right after this class, or do you upload it the next day?
I usually upload the homework after the class. So it
Okay.
will be coming today.
Okay.
So let me just show you how to do x squared plus 4 times x squared minus 6 plus 58. All right. Okay. So can you see the board? Can everybody see the board? That board? Hello? Can you hear me?
Yes, we can.
Okay. So so we got the x squared. I forget. I think it's x squared plus 4 times x squared minus 6x plus 58. Is that right? So what you do, you're going to distribute the x squared with everything in x squared minus 69x. And not 69x, but 6x, I think. So let me just erase that. Oh, okay, x squared plus 4 times x squared minus 6x plus 58. Okay, so just distribute the x squared, to each of those 3 terms. So you're going to get x squared times x squared. So you're going to get x to the 4th, add 2 and 2, right? And x squared times negative 6x, you're going to get a negative 6x to the cube, isn't it? X squared times 58, you're going to get the 58x squared. And then you distribute the 4 to those terms, 3 terms also. So 4 times x squared equal to 4x squared. 4 times negative 6x equal to negative 24x. 4 times 58 equal to 232. So that's why you got those things. And then you just combine, those all of those terms, but it turns out you can only combine these two to get a 62x squared, right? So if you combine those, you get x to the 4 minus 6x cubed, 50x squared with 4x squared gives you 62x squared, right? And negative 24x plus 232. Does it make sense now? Is it good? Is anybody following me? That's how you do the multiplication of polynomials. Can you see it?
Yes.
Okay. Does it make sense? It's just the folio, the same kind of technique with folio. It's just the distribute, more terms this time. Any questions about this?
No.
No? Okay. So you're going to multiply this factor with that factor. Okay. So what you do is just multiply x squared, the first term, in the first part with all the terms in the second part. So x squared times x squared, you're going to get the x to the fourth, right? You know how to, you add exponents, 2 plus 2 is
Right.
4. And then you multiply x squared with negative 6x, so you're going to get the negative 6x cubed, right? X squared times x is x cubed.
Yes.
And then you multiply x squared with the 58, you get the 58x squared. And then you multiply 4 with the x squared with the 4x squared. 4 times negative 6x, 4 times negative 6 is negative 24, you get negative 24x. And 4 times 58, you get the 232. And that's how you do it. Good.
Yes.
All right. And try to do some practice, okay? In the homework. That's why I give you the homework. I found, it's really necessary for you to practice. I know, some people not quite used to, quite not familiar with those. Yeah, so please practice, okay? Any other questions?
But yes, I have a question real quick.
Yeah. Yeah, what's the question?
I see you with where did you get your 6?
Where did you get 62? Oh, you add 58 x squared with 4x squared.
Oh,
You combine,
okay,
yeah, you combine like
my
terms,
like
right?
terms. Okay.
Yeah. So that's how you do it. It takes a little steps. Any other questions? Okay, if there's no more question, I'm going to stop the recording and take the roll now. All right.